because we really don't know the distance.
Oh, because it's not right on ground. Oh, okay, gotcha.
No, we don't know what this distance is. They haven't told us. Okay, just the only thing we got to know is the horizon line's above the ground line and it's a bird's eye view. If this was approximately 6 feet, we'd call it a human's eye view. Okay, but they're both bird's eye views. Right? If it was a ground line view, this would be doubled up, right? They'd both be here. If it's a worm's eye view, the horizon line would be down here. They set it up the same. Still a side view that has height. Now, they brought in a top view that has width and depth. Notice what they did on a 2-point perspective. They rotated this guy, as shown back in step 2. They rotate it 30 degrees off of plane. Again, pay attention. What is on the picture plane? That one corner. Therefore, that one corner is going to be what? True size and shape, and that's going to allow you to build this whole object, is that one true shaped line. When you look at a 2-point, generally, I mentioned yesterday, you usually only have one line that's true size and shape on the whole drawing. No, you don't know where it is unless you drew it. That's the guy that's going to control this whole thing. All right, then they moved the station point. In this case, they've moved it right in the front because they rotated the object a little, so now we can come more into here and see both sides. They got their 30-degree cone of vision. Again, if I wanted to see more of this, I would slide it over this way. Same concept. Okay. Now, the only thing that changes here is now, how do they locate the vanishing points? Okay. Here is my depth axis. Here's my width axis, correct? Notice here, they take the angle of this width axis. Come from your station point at that same angle. So in CAD, you'll just copy these two lines to the station point and then extend them to the picture plane. Once you hit the picture plane, draw it straight down to the horizon line, and that defines your vanishing points. So here's the vanishing point for my depth axis. There's the vanishing point for my width axis. The vertical axis on here, or Y, is just straight up and down because we are not vanishing that. Got it? Any questions?
Yeah.
Can you repeat that? So you draw a line parallel with, so last time you said it was depth, but this time it's the width, so.
It's width and depth on this one because we went from a 1 to a 2-point. On a 1-point, you're only vanishing one plane, so you only need one vanishing point, and it was the depth axis. Okay. Now, if you go back and look at that 1-point perspective, you'll see all the horizontal lines are horizontal. They do not vanish. All the vertical lines are vertical. They do not vanish. They're all parallel to each other. The depth axis, though, vanishes. They are not parallel to each other. Therefore, you're starting to bring this in at the same way your eye sees it. When you go to a 2-point, we've got 2 planes we're vanishing, width and depth. So here, the only lines that are parallel, if you look down into the finished object down here, these vertical lines, they don't converge on each other. They're all just straight up and down. Now, the horizontal lines are the width, all vanish to this point. All the depth ones go to this point. They all kind of converge to that single point. Let that gel in your mind. Let's take a 5-7 minute break. We're going to come back and we're going to do 1 and 2 points of those 2 figures we had sitting on the board, and we're going to draw them together as a group.